Now we'll move on to areas between two curves, or a line and a curve. And so it could look something like this. And we want to find this bit. Or could look something like this. And we want to find this bit. And basically, you just do, if you call this f of x, and this is g of x, the area is just equal to let's call this A and B. A, B, we do the one above. Which, by the way, is also equal to so if we do an example such as y equals x minus 3 squared and y equals 2x minus 3, and it's something like this. We have to find this bit. What we would do is we would do integral of 2x minus 3 and to find the limits we would have to do a simultaneous equation. So x squared minus 6x plus 9 equals 2x minus 3, x squared minus 8x plus 12 equals 0, x minus 6x minus 2 equals 0. So these points will be x equals 2 and x equals 6. And then we'd subtract 3 squared dx. So that's minus x squared minus 6x plus 9, so then that becomes minus x squared minus 6x, so that's plus 6x, and minus 9 dx. So that's minus x squared plus 8x minus 12 dx between 2 and 6. And then so now we'll integrate. And then you would go and then you'd subtract that with 2 substituted in instead. And that will give us 10 2/3, and that'll be units squared. Additionally, I should also note what might happen if part of it is above the x-axis and part is below. I will straighten out that axis because that's horrible. Do that, and then that's A and B. Look, you don't do anything else. If that's f of x and that's g of x, you'd still do integral f of x minus g of x dx between A and B. You'd still do that. Because imagine if you simply moved everything up by c to make it above the x-axis, you'd get AB f of x plus c minus g of x plus c, right? And those c's would cancel out. So you'd still get this. And remember, sometimes it might be two different curves. So, for example, you might end up having to do something like between x squared, well, so that's x squared, right? And no, like let's say like x minus x squared, and then something like root x plus 2 or something, and then you have to find this area. And it would be the same thing. You'd do the integral of root x plus 2 dx, which is this is just x to the power of half, by the way. And then you'd subtract in between a and b, and then you'd subtract the integral of x squared dx. And this works because, I mean, it's like calculating the area of this, right? Because that's the area under that line, and then it's subtracting the area under this curve. So that would give you that remaining area, wouldn't it?